Okay, so I want to show you my solid state Bedini simple schoolgirl circuit. You notice the difference between this Bedini circuit and the ones that you use a wheel. This does not use any moving parts. It's all solid state. And here's the circuit diagram for the trigger coil, which is right without the bars, and the primary coil, which discharges and charges up with radiant energy this 12-volt battery. You don't need the 18K or the 10K resistors, and you probably use 50 ohms or even less than that 2 kilo ohm. And both of these, this would be a lead acid battery that you can get anywhere. It's a car battery or a battery out of a little ATV that kids drive around in. Amp meter. And right now this coil, and the coil I have actually is 6 transistors and 6 coils with one primary coil. Another thing that you should get, that if you want an oscilloscope, this only costs $99, if you can see that. Instead of $1,000, this is a digital oscilloscope. And but the transistors here, they're off-the-shelf transistors. TP22, I think, at 1.4 amps each. And right now it's drawing. Get over here and look, show you that it's just above 5 amps. So each transistor is a little less than 1 amp. That's good, it keeps the heat down. Of course, you can rig up a little computer fan if you want to keep the heat down. And the terminals, there's no soldering. It's all Radio Shack. So just screw down the parts. Need 6 diodes for each transistor. You can refer back to the diagram if you're interested. But there's a neat little trick you can do if you have an oscilloscope. All you need to do is take a coil that's just a regular coil, take one end, ground it to the probe, and the other end on the probe, and you can take sort of interesting patterns off of the coil. And what you see here is as the spike goes up and then it discharges, it makes a wave pattern, and it dissipates all the way down, and that sulfates the battery. So you can charge, this battery's charged up to 15.22 volts. And if you find a battery that's dead, you can rejuvenate it. The more you discharge a dead battery, or any battery, a car battery, any lead acid battery, the more you discharge, charge, discharge, charge, it'll hold the radiant charge even more. This is probably the limit. You don't want to overcharge, it'll blow the battery or short it out. And if you need a power supply, just take an old computer with a power supply, and most computers have 12 volts positive, 12 volts negative, 3 and 3. Just tap off of the 12 volts. And a multimeter, of course. I recommend, it doesn't really matter which brand, but there are basically two kinds of inverters. There's the pure sine wave inverter, which is extremely expensive, or you can get a square wave inverter, which is kind of like a digital inverter. And this one costs $60. A 400 watt pure sine wave would cost probably $260. So there's a huge price difference. And sometimes it says it has adverse effects on motors, but I haven't. You can hear a difference. I'm not sure over a long time if that would. But I've plugged in my laptop, the light bulbs, and plugged in all kinds of stuff. And this is radiant energy. That coil is 6 coils, unlike this chart, which only has 1, and the smaller one is the trigger. So there's actually 7 coils, the trigger, and 6 larger gauge coils. And you want to use 17 gauge for the radiant coils that are going to discharge into the battery, and a 21 gauge trigger. Of course, 21 is thinner gauge than 17. So, and that creates an oscillation. It oscillates back and forth like this. That simulates the wheel that was normally there to trigger, but since it's oscillating, the trigger happens without any moving parts. And this thing will auto-tune to whatever battery size you're charging. You can hook the leads up to some water, to some stainless steel, produce hydrogen. And here's a diagram of how you should wind your coils, because that matters, positive and negative. As you can see, both coils are tied to, well, the 6 coils I have are tied to the positive of the primary, which is on the left, and the charging side is on the right. And when this coil collapses, this coil here collapses, it reverses its energy. So it comes positive, and it goes into the battery and charges. Actually, it goes this way into the battery. But while it's charging, it's blocked by this diode. When this flips, it activates the switch because it hits the base of the transistor, discharging the coil in a reverse fashion into, actually it shuts it off, so it goes into, well, anyway. So that's the diagram, and it's very important, the winding. Hope you enjoyed this video.